This video is on inverse functions, part 1. So first of all, let's talk about what an inverse function is. Often it is necessary for us to represent a formula or a function for undoing the operations that we have performed on a number. The formula or function is called an inverse function. The inverse function is a function that takes us back to the place where we started, before the original function was applied. So let's take a look at some non-math examples. For example, let's say that the function is sit down. So if we sit down, how could we go back to before we sat down? So to undo sitting down, you would just stand up. So there was an inverse to that. Okay, let's say we started out with open a door. If we want to get it back, we would just close the door. Let's say we turn on a light. If we want to get it back to what it was, we would turn it off. So these are all examples of stuff in real life that we can get back to what it was before we performed the function. Here are some examples of real life things that don't have an inverse. For example, if we crack an egg, there's no way to get it back to the whole egg. Once it's cracked, we can't. It cannot be undone. Okay, let's say you cut your hair. Yeah, you can let it grow back. But when you cut your hair, there's no instant way to put the hair back on your head, right? It's not gonna, you can't hot glue it on or anything like that. It can't be undone. All right, here's another example. We spill a drink. There's no way to get it back, right? When you spill it, it's all been evaporated or onto a table. You can't put it back into your cup and have it fully restored to what it was. So the point here is not everything will have an inverse, a way to get it back. Now let's do some simple math examples. So let's say the original number is 3, and let's say what I perform to it is I add 2 to it. So now the number is no longer 3, now it's 5. So my question is there an inverse to adding 2? Is there a way to get it back to 3? And if I have 5, and instead of add 2, I subtract 2, now I get my original number. So it had an inverse, subtracting 2. Okay, so let's say our original number is 5. And let's say I take 5 and I multiply it by 4, now I'm at 20. Is there a way to get back to 5? So if I multiply by 4, the inverse would be to divide by 4. And now we're back to that original number. So it has an inverse, multiplying by 4 and dividing by 4. Now let's say we had -3 and we square it. So I'm going to take -3 and square it. So -3 times -3, that's 9. So is there a way now to get it back to -3? So if I have 9, and I would do the inverse of squaring is to square root. If I square root 9, that's 3. It doesn't get us back to -3. So there would be no inverse to squaring a number. If instead this number was +3, then it would be possible. So for example, if this was 3 and then you squared it, you would have 9. And then if you square root, then that one would be yes. So again, all you need to get out of this is that not everything has an inverse, and that some have inverses. And an inverse is just a way to get back to the original. So let's do a couple more examples to help us see and understand what an inverse is. So first of all, if we want to say that something is the inverse to another function, if I had function f and I wanted to say that another function was its inverse, I would use the letter f, and then I would put a little -1 in the upper corner here. So that means the inverse of f. Let's say we are given the function f, such that we had the ordered pair x comma y. So for example, just to give it numbers, let's say the ordered pair was, let's just pretend, was 3, 4. So that ordered pair was an ordered pair for function f. The inverse function so f of -1 would consist of the ordered pairs that are flipped. So instead of x comma y, it would be y comma x. So what that means is the inverse is going to have, instead of 3, 4, it's going to have 4, 3. So when a function is the inverse to another one, their input and output is flipped, is switched. So if the input and output is switched, then it should make sense to us that the domain of one function is going to be the range of the inverse. And the range of f is the domain of the inverse. So everything's just switched. So for example, if I had a function with those 4 ordered pairs and I said, what would the inverse be? The inverse would be if we just flip. So instead of 0, 1, we'd have 1, 0. And instead of 1, 2, we'd have 2, 1. Instead of 2, 3, we'd have 3, 2. So we're just switching all the x's and y's. And instead of 3, 4, we'd have 4, 3. So that's what an inverse function does. It switches its x and y. So if you're confused right now, maybe this will help make sense. So I'm going to pick a random number. So I picked 4. So I'm going to input a 4. So I'm going to find f of 4. So I'm going to take out the x and plug in the number I picked, which is 4. And we get 18. So the ordered pair would be, I plugged in for x 4 and got an 18. Now we're going to do the same thing, and I'm saying that this function here, that equation, is the inverse to this one here. So now let's start with what we got here. We got 18 here, so this time we're going to plug in 18 into the inverse. And we get 4. So the ordered pair here is we plugged in for x, 18, and we got out a 4. Now what you need to see here is, do we see that these, if I have a 4 and an 18, it's just switched around? Because this is the inverse to that. So that will always happen if two equations are inverses. Their x and their y are switched around. So just to demonstrate that one more time, how about instead, and you don't have to write this in your notes, you could just watch this, instead of f of 4, let's say I plugged in f of, let's go with 3. So if I plug in 3 this time, we would get 13. So when I plugged in for x, 3, we get out a 13.